Okay, so our last section in chapter 8 we're looking at is 3 equations, 3 unknowns. So these are similar to what we did before, the 2 equations, 2 unknowns, but you see you now have 3 different equations and 3 different variables. I mean, you can do these up to, really an infinite number of unknowns, and you'll learn in college algebra different ways to do it. We're going to do them algebraically in here, but you can do them by matrices. There's lots of different ways that you can do them. But when you're solving 3 equations, 3 unknowns, the first thing you want to do, well, I like to number them. So we've got number 1, 2, and 3. So we've got 3 equations. And so you're going to take 1 and 2 and get rid of a letter. That's not really algebraically talking, but cancel a letter out. Then you're going to take 2 and 3 and get rid of the same letter. That's important, that we've got to get down to the same letter, and that leaves you with 2 equations, 2 unknowns, like we did in like we did in 8.1 and 8.2. And so you'll just solve down for that letter and then start plugging it back in. So before you decide which letter to look at, I like to look in the column here, and you want the one that doesn't have very many coefficients. So do you see this? The x's only have 1 coefficient, the y's have 2, and the z's have 2. So the one with the least amount of coefficients is the easiest to get rid of. So I'm going to choose to get rid of x. And so I'm going to kind of mark an arrow here that x is what we're going to get rid of here. So we're going to take 1 and 2. Let me just cover up. So we're going to look at I'm sorry, the camera's shaking, just these top 2 equations. Let me get a piece of paper. Hold on. Let's do this better. So we want to look at 1 and 2 and get rid of x. Keeps going out of focus too, guys. And so in order for the x's to cancel out, let me do this in green. Do you see that this would need to be a -2? I'm sorry, I'm going to zoom it out and see if it focuses better. So we need to get rid of the x's. So in order to make these opposite, I would need to multiply everything on the top by -2, including this 7 over there. So this becomes a -2x, a -6y, a plus 12z equals -14. Now these are kind of long to work out, so even myself, I'm going to make sure I did that right. -2, -6, +12, -14. Okay, and then 2 stays the same, so I'm just going to go ahead and rewrite it here. So this becomes a 2x minus y plus z equals 1. I'm just rewriting the second one. So now when we add them together, just like we did back before, these cancel out, and you see we're going to have a -7y plus 13z equals a -13. So I took 1 and 2 and got rid of a letter, and it gave me this. And I always put a square back around that because I'm going to come back to that in a minute. Okay, so I took 1 and 2 and I got rid of x. Okay, now I'm going to take 2 and 3. I'm going to look at these down here and get rid of z. I had already written this on here. Hold on. Oh. Okay, so now we're going to look at 2 and 3 and get rid of x. I already did 1 and 2 and got rid of x, and it gave me this. And now I'm going to look at 2 and 3. So I'm going to cover up the first one because we're already done with that. And look at these 2 and think, okay, how can I get rid of x? I would need to multiply by -2. So whatever I do to that one, I have to do to all of them. So on this one, the first one's going to stay the same because we didn't change anything on equation 2. But the second one's going to become a -2x, a -4y, a -4z equals 2. And like I said, I always want to double check because these are a lot of work to find a little mistake going forward. So I think I did all that right. Then we're going to add them together. That's going to cancel out, leaving me a -5y, a -3z equals 3. So do you see I took 1 and 2 and got rid of x? I took 2 and 3 and got rid of x. And now what I have is 2 equations, 2 unknowns. So let's do these in red. So I'm just going to rewrite them again so we see them next to each other. And now it's a problem just like we had in 8.3. Get this up. Okay, so now we got to look at them and decide which letter do we want to get rid of. I'm going to pick z only because they're already opposites. And so all I have to do is multiply this one by 3 and this one by 13, which is going to make them both the same number. So I just have to do the top by 3 and the bottom by 13. So I'll just do this in blue then. So 3 times negative 7 is a negative 21y. 3 times 13 is a 39z. And 3 times 13 is a negative 39. Then on the bottom, 13 times 5, what is that? 70, wait. Sometimes I can't think when I'm 65. So 13 times 5 is a negative 65y minus a 39z equals a 39. So now when we add them together, this cancels out. And so we really have a negative 86y equals negative 39, and positive 39 is a 0. Divide by negative 86. So y equals 0. So we solve for our first one, but we have to solve for all 3 of them. So we have one answer, but we've got to find 3 answers. So now we're going to work backwards. So we have one answer, so we're going to go back to one of the 2's. It doesn't matter which one. I'm just going to plug it in this one just because it's there at the bottom. And we're going to plug in y equals 0. So we get a negative 5 times 0 minus 3z equals 3. 5 times 0 is just 0. So I just have a negative 3z equals to 3. So divide by negative 3, z equals negative 1. So now I have 2, so I have to go back to one of the original 3. I can't plug a 0 into here because it still has 2 unknowns. And for 3 unknowns, I have to know 2 of them to solve for the third one. So you can pick any one of these equations you want. It doesn't matter. I'm just going to pick this bottom one. I am going to rewrite it just so I make sure I don't miss any of my signs and everything. So that's the original equation. And so I don't know x, but I know that y is 0. And then I have a 2 times z is negative 1 equals negative 1. So 2 times 0 is 0. So I just get an x minus 2 equals negative 1. And then add 2, x equals 1.